Alright, welcome to the lunchtime video. We're gonna devote the video today to Cspf tracing. I'm gonna start off this video by verifying that I uploaded the last one because I'm so in between things that I need to do that. It's just a good idea. So let's see here. We've got my channel, we've got my studio. Okay, and we'll see. I think I already saw it there. So it is TED pipe 5. So yep, we're going to be working on TED pipe 6. So, and as I said before, it's going to be all about Cspf tracing, which is going to be detailed in this documentation here, examining a Cspf failure. So let's see here. I think the last one, what we did. Now one thing to remember, and actually this is something I got wrong. So I tend to think of the word tracing as kind of determining a traffic flow. That's really what I consider the word tracing to me. But in Juniper, tracing has a different meaning. What it means is using trace options to see debug. So it's basically in Cisco, the word debug means tracing. And then general networking, Juniper, you probably hear that as well, tracing. It just depends on what the network engineer would say. Personally, I do my best when I'm acting professionally to just try to use plain language and get rid of the jargon, and if there's a concept that requires complex jargon, maybe like keep that to myself a bit. But I definitely screw up a lot in that regard. And just throw out crazy jargon. Oh, this is at layer 2, and nobody knows what I'm talking because I'm just chunking down a lot of information into its jargon. But that's not what this video is about. That is something to think about if you want to get into this field, though, is how can I communicate with people who haven't spent the time or working on, studying and knowing what I know, because you're not going to be talking only to other experts. You're going to be talking to customers. You're going to be talking to co-workers in a different department. You're going to be talking to management. It's really important to be able to professionally communicate in contexts other than those that are purely technical. Alright, so let's move on to this next one. So this is verifying a Cspf failure. So we did have a Cspf failure in the lab. Let's take a look at that closer. Now I did disable Cspf, so we're going to enable that so that we can see the Cspf failure. Okay, so here's the lab. Let's take a look at the show MPLS LSP detail output. Okay, so we've got, so no route towards destination, but it didn't attempt to do a Cspf failure. So let's get rid of that configuration that disabled Cspf. Okay, and we'll try to get rid of this on just this router, see if that makes a difference, but I think it will need to be deleted from all of the routers. So that's good news. It looks like it only needed to be deleted on this one router. I kind of would like to delete them from all of them though, just to kind of give myself peace of mind. But I do think it only needs to be on this one. But let's delete them, delete it from all of the routers, just for some peace of mind. Oops, it's going to be no CSPF. Perfect. Okay, so we've got it off of there. It's not completely necessary, but we'll get a good peace of mind that things will fail in a way that is predicted. So let's go through. Oops. So I'm going to need to open the documentation up again. There it is. And then put it side by side. So we already did these commands. We can see that it's down. Now they want to run, I think I read this in the last video, so this is moving on, examine the CSPF log file. So after you have confirmed that LSP is down, obtain more information about the possible cause of the failure. To obtain useful information from the CSPF log file, make sure that CSPF tracing is configured on the ingress router. So let's do that. I'm not sure what they mean by the ingress router. Okay. Oh yeah. It's weird. It's like flipped. So like this is the ingress router, even though it's sending an LSP out to the other. The ingress and egress I found, and export and import, I found those terms to be very unintuitive when it comes to working on Junipers. But this PE1 is the router that requires trace options to be enabled for CSPF. Okay, so trace options flag, we've got a number of things. Let's do CSPF and then set trace options file, and it's going to be CSPF. Commit and quit. Okay, so now we can follow along with the instructions here. Monitor start CSPF. Okay, and now let's do a So I'm not sure how they got this file, CFPF failed 3. They either, so it looks like it's not going to rerun until there are changes in the traffic engineering database. So I read all this last video, I think, so let's keep reading the next part. So examine the traffic engineering database. Purpose. Examining the traffic engineering database is another way to locate the node that should meet the constraints but does not. Once identified, you can concentrate your troubleshooting efforts on why that node is not being represented accurately in the database. The contents of the traffic engineering database are consistent among all routers within a given traffic engineering domain. Therefore, you can issue the show TED database command from any router in the same traffic engineering domain to obtain more granular information about the Cspf failure. So let's do that on this one. Cspf integrates topology link state information that is learned from the IGP traffic engineering extensions and maintained in the traffic engineering database. The information stored in the traffic engineering database includes attributes associated with the link, with the state of the network resources, such as total link bandwidth, reserved link bandwidth, available link bandwidth, and link color. When calculating a path, the Cspf algorithm factors in user-provided information such as bandwidth requirements, maximum allowed hop count, and administrative groups, all of which are obtained from user configuration. See Figure 1. Okay, so let's follow through this flowchart. We've got a number of arrows. We can see the arrows are pointing this way, so it looks like the place to start is here. So this is extended IGP, ISIS, or OSPF populate the traffic engineering database. So then we get a link state database, which I'm going to do a monitor stop here. So we're going to have a link state database of some kind. Let's check it out for OSPF. So OSPF database. Yep, so here's I think this is the link state database. Okay, so yep, we can see here it does say link state database. So this is OSPF AS scope link state database. Now I noticed something kind of unusual about it. It's very small. I was expecting it to be bigger. So I'm not sure why it is so small. Let's try to find a link state database for ISIS in the other AS. So here it's much easier as far as the help menu is concerned, because we can see it says show ISIS link state database. Much easier to be able to tell which command to run. And we've got a much bigger database here. Now we're not going to have any level 1 because we disabled all that. So if I do show IS adjacency, we can see we've only got a level 2 adjacency. And if I do a show configuration pipe display set, pipe no more, pipe match ISIS, you can see we have disabled level 1. So we've got 1, 2, 3, 4, 5 links in our link state database. It's kind of interesting that they've got level 1 attributes still, even though those have been disabled. But we've got 5 LSPs. Now LSP has a different meaning when it comes to ISIS. It stands for Link State PDU. I believe I might need to check what the P stands for, but I do believe the LS stands for Link State. It doesn't stand for Label Switch Path. That's what the acronym LSP stands for in the context of MPLS. So a little bit confusing when you're using ISIS because you're going to have a duplicate acronym whose meaning depends on the context in which it's used. So if it's used within the context of ISIS, it's going to be a link state PDU. But if it's used in the context of MPLS, it's going to be a label switch path. Okay, so one thing I'm kind of confused by is why this is so small. I guess it's because it's a external. It's the only external that we've got. So this here is the size that I was expecting. So I think there's no issues. It's just the verbiage around this command is not very good. This is still a link state database. It just doesn't say that the same way it does down here. But the output is going to be just fine. Okay, so we've got our extended IGP link state database. We looked at that. So now we've got the TED, traffic engineering database. This is shared by all routers in the traffic engineering domain, so it's going to be the same. So let's look at it again here. Okay. Then we've got our Cspf computation. Let's see if there's a way to check that. Don't see anything. So we've got an arrow pointing down this way. We can't go here yet. Explicit router ERO. This is a aspect of RSVP. Then we've got our RSVP signaling is complete once our explicit router ERO object is finished. Then we've got our routing tables updated. And then we've got, so you see there's no arrow going in, there's only an arrow going out. That's because these are constraints you can add that will affect your CSPF calculation. So really you're gonna kind of start here if you're a user, if your IGP is already set up. And you can color your links, kind of make it more clear which links you want to belong to what. You can reserve bandwidth on the links to make sure that they don't get oversaturated. And of course you can do that for your LSPs as well. An LSP is basically a virtual link. So just as you could change the link color and the reserve bandwidth for your physical links, you can do that for your virtual links, but because they're virtual, you've got some extra options: explicit route, hop limitations, and priority. Alright, so to examine the traffic engineering database, enter the following Junos OS CLI operational mode commands. Show TED database extensive. Okay, so I'm examining it. I think I'm done examining that. Now I will examine the other one. I got a phone call. Hello? I keep getting spam. There's a scam where people will say like, oh, your car warranty is expired and you need to like pay for it or something. It's like, I don't even own this. Like I bought a car like last year. Like I don't even have like the car they would be talking about, because they're talking about a car in a different state, is not the same car I own. So I don't know why I would pay for a warranty for it. Okay, so let's okay, so now I'm checking in on the other one. Let's narrow it down to what they want to find here. Oh, so we've got to specify the node IDs though, so this command's gonna fail. Okay, so system ID. So let's narrow it down to this one. Okay, and then let's add those match filter strings back in. Perfect. Okay, so now we got a pretty clear filtered down. Yeah, I like this output a lot better. Let's just do that for all of them. Now some of these don't list the color at all. I'm gonna clear off my screen. There we go. Okay, so here's the meaning. Sample output 1 from ingress router 1 shows a wealth of information on each node in the link. Although only a portion is included in this example, the output shows the total number of ISIS and INET nodes in the traffic engineering domain. The portion of the traffic engineering database shown represents a node R5 and a type field indicates RTR router. The type field could also indicate NET network if the node were a pseudonode. The node R5 has 3 input and output links that are running ISIS level 2, protocol ISIS-2. The links lead to nodes R1, R4, and R6. The local address and remote address for each link is specified. The information on each node includes administrative groups, color, metrics, static bandwidth, reservable bandwidth, and available bandwidth priority level. The information contained in the traffic engineering database should be the same across all routers in the same traffic engineering domain. For a detailed description of the fields in the output of the show TED database extensive command, see Junos routing protocols and policies command reference. Sample output 2 shows filtered output that allows you to focus on exactly what's missing or incorrect. Both outputs confirm that the link between R1 and R5, 10.1.15.0/32, is associated with the red color, while the link between R5 and R6, 10.1.56.0/32, is not associated with a color. In the network shown in Cspf topology and administrative group coloring for the LSP to establish correctly, link 10.1.56.1 must be associated with the red color. Okay, so let's check the administrative group configuration on R5. The purpose of that is to focus on R5. So the purpose of focusing on R5 is to determine which interfaces are associated with the red color and make any necessary functions. So we're not going to have any interfaces associated with the red color. I probably will need to learn about admin groups for this, but we're definitely not going to have that interface. It looks like it's just as simple though as going edit interface 0, and you're going to be adding it to the physical link, and then oops, so nope, you can see never mind. So it's going to be in the protocol's MPLS hierarchy, and then it's just as simple as whatever port you've got added to it. I've got I don't have any physical ports added to mine, so hopefully I'll have the same options. Yep, so I still have the option for an admin group, so now I can do red, blue, whatever I want. But I don't think I want to do anything, so we're just going to move on. Sample output 1 from transit router 5 shows that at the edit protocols MPLS hierarchy level, interface SO001 is incorrectly configured with the admin group red statement. The SO000 interface should be configured with the admin group red statement. Sample output 2 shows the steps taken to correct the configuration. The administration group has been deleted from SO001 and SO000 is now associated with the red color. Sample output 3 shows that LSP R1 to R6 is established. Okay, so let's see here. Let me think. So, yeah, so unfortunately, I've mentioned in the previous videos, and I've actually kind of given it more videos than I wanted to, so I really got to cut my losses and move on. There's just too much on the test to focus on any one thing for too long. So I'd love to know why this LSP is down. Well, let me put it this way. I know why the LSP is down. It's down because there's no route towards here. Even though there is a route towards there, you can do show route, and you can see, yes, there is a route there. So I'd love to know why Cspf, or why it thinks there's no route there when there is. Especially since the from is specified here. And you can see that I can ping that address when I give it that same source address. So I'm really not sure what's going on. The latency is really high, surprisingly high. But yeah, I'm really not sure what's going on. And I wish I could figure it out. I do have another, I would say, like half hour to work through this. Now, one thing I have noticed, if I do type local, and I specify one of the sources here, I can't ping. So, and the reason for that is because if I go over to R2, and I do a show route here, I won't have a route. But that, to me, is kind of throwing me for a loop because, well, unless here, let's see if I'm advertising my static routes into my IBGP session. Or sorry, my directly connected ones. So directly connected, Yeah, so I am. So I don't understand why it's not. Let's see what P1 is advertising over to the other AS. Show route, advertising protocol, BGP, and then I believe it was .5. Okay, so you can see it's missing that 0.1. It's not advertising that one. Oh, and I'm hearing a ringing or something, so I'm gonna put on these. I don't even have a phone that makes that ringing noise. Oh, and they're on backwards. They fit better this way. Okay, so we've got direct, OSPF, BGP. So it should be I don't understand why it's not advertising the local routes that are the direct routes here that I have. Yeah, so direct to IBGP. Yep, then we're gonna accept those. So, and then I've got my export statement. So let's do a show route advertising protocol, BGP, and then the neighbor is .5, I believe. 4? Yeah, there we go. So yeah, we can see we are advertising it. Let's see if we're receiving it. Oops, BGP. So are we receiving it? Yep, we are receiving it. So why are we receiving it, but we're not advertising it to the other side? Let's look into that. So we'll do a show BGP summary. Okay, and then we'll do a show BGP advertising. Oh, sorry, show route. Advertising protocol BGP 10.0.5.2. Yeah, and you can see we're not advertising. Let me get the previous. Yeah, so we're not advertising the routes that we received except for this route here. So let's do a show configuration protocols BGP pipe display set, and then let's do a show configuration pipe display set pipe no more pipe match and LRI to BGP. Okay, so let's see here. Okay, so we do have route filters, and you notice something kind of convenient here. We've got the things specified in the route filters are the things being advertised. So let's get rid of these statements because they don't seem to be doing anything, and just add route filters for the routes we're going to need. Oops, yeah, we've already got 3 in there, so we're going to be doing this .1. Yeah, we've already got that one in there. So we're going to need to add this one. Okay, so let's see if oops, so aha, perfect. So now it's working. So let's see if the Cspf MPLS LSP can come up now. So it's still down. So hopefully, so now we've got something a bit more specific here. It says that there's no route towards this address. So I think we're going to need to make similar changes on P1, where we include the link here in what is being advertised to the other autonomous system through eBGP. So let's do a show route. And we can narrow that down. We'll do a show route protocol direct. Okay, and I'm gonna. This video is going to go until like 1:20. I was working with a team at work and we went a little bit over 12 o'clock. So, so this .7 here, we're going to be exporting on P2. Yep, so we'll get rid of all these because if I do that advertising, so if I do a show route, let me do a show BGP summary first, and then I'll do a show route advertising protocol BGP, and then the reason I did this command is so I can easily see what neighbor I need to specify. So we can see it's only advertising what the route filter did. These statements are having no effect, so let's start by removing them. Okay, and then let's add another route filter for the directly connected subnet on PE2. Okay, so we're good to go. Yeah, so let's see if it's up now. Still down, but remember it's not gonna attempt to go up for another 17 seconds last time I checked. Okay, so we can see it did attempt recomputation, but it's still got a problem where there's no route towards that address. So one thing I think I'm going to do, especially in the interest of time, just to absolutely kind of cover my tracks, is expand out these route filters. So that anything will be advertised. So let's see here. Show route advertising protocol BGP 5.1. So you can see now we've got that specific route. But I think I'm going to just advertise 10/8. So I'll show you how I'm going to do that. So We'll do edit here. Perfect, okay, and then we'll delete the existing route filters. Okay, and now we'll set a new route filter, and it's going to be just the whole 10.0.0.0/8 network, and it's going to be or longer. So anything that's, because remember, let me get out a notepad here to make this very clear. The longer statement might be very unclear what that means, and apparently I can't use my computer right now except for to go to the Microsoft Store. Oh no, I get it. I was just confused how my mouse was working. Since on my second monitor, I'm looking back at my first monitor. But when we've got so we've got our /8. We're talking about the bits to the left. We're going to have all of those bits come on to be a part of our subnet mask. So when we say or longer, we mean we're going to move this bar over, and we're going to have more bits belong to the network portion of the address. So that's the option we're going to go with, is the or longer option. Oh, actually we can just go, let's just go with address mask. I think that'll be better. Oh, wait, never mind. Let's go with or longer actually. Okay, so now let's see what we're advertising. Perfect, so we're advertising all the routes. Let's try it on the other side as well. Oops, it's going to be exact. Okay. Perfect. Okay, so now let's take a look at what's being advertised here, and hopefully we'll have a lot more things showing up. Perfect. So, yep, and we're going to have more on this side because we've got an additional router over here. So hopefully the computation will work now. And if it doesn't, then okay, so it's going to recompute in about 20 seconds. So we'll make sure we're going to see as soon as that recomputation happens what the results are. 5 seconds. And you'll notice it's a little bit laggy and buggy right now. Oops. So, but we still don't have a route, whatever that means, because very clearly we do have a route. So I don't understand why we don't have a route. Let's take a look at the database. So, and let's take a look at this to section and see if we have actually got one for the .7. Aha! So this is interesting. We can see here's our error message here, no route toward 255.0.7. And when we look into the TED database, sure enough, we don't have a route to .7. So it's not lying. It's just I was checking the wrong thing. This is not saying there's no route in the routing database, inet.0, or the routing table. It's saying there's no route in the TED database, and that is true. You can see there isn't one in there. These are just the routes that belong to this AS. We're not getting the routes in the traffic engineering database from the other AS. We're going to need to have those added somehow. And now the way we can add them, I believe, was outlined in this prior documentation. But unfortunately, I think I'm going to be out of time, and I'm not sure if inter-AS LSPs are going to be a big part of it. So unfortunately, I kind of hate to do this, but I'm going to have to skip this. I hate to do it because I feel like I'm finally kind of understanding it. Let's take a look. So inter-AS. Okay, so I'm gonna read this whole section, and then I think that'll be it for this video. I'm gonna take the L just in the interest of working on other things. So this is enabling inter-AS traffic engineering for LSPs. Generally, traffic engineering is possible for LSPs that meet the following conditions. Both ends of the LSP are in the same OSPF area or at the same ISIS level. The two ends of the LSP are in different OSPF areas within the same autonomous system. LSPs that end in different ISIS levels are not supported. The two ends of an explicit path LSP are in different OSPF ASs, and the autonomous system border routers ASBRs are configured statically as loose hops supported on the explicit path LSP. For more information, see configure explicit path LSPs. Without statically defined ASPRs on LSPs, traffic engineering is not possible between one routing domain or AS and another. Therefore, when the ASs are under the control of a single service provider, it is possible in some cases to have traffic engineered. However, so this is something you can do. To have traffic engineered LSPs span the ASs and dynamically discover the OSPF ASBRs, linking them. ISIS is not supported with this feature. Inter-AS traffic engineered LSPs are possible as long as certain network requirements are met. None of the following limiting conditions apply, and OSPF passive mode is configured with the eBGP. Details are provided in the following sections: inter-AS traffic engineering requirements, inter-AS traffic engineering limitations, configuring OSPF, passive TE mode. So it sounds like you have to have OSPF on both sides, which is surprising to me because in the example I was using before, which I guess isn't in my notes. I thought it was. I don't understand why I can't find it in my notes anymore. But in that example, one side was using OSPF and the other side was using ISIS. So it's really surprising for me to read that both sides have to have ISIS enabled, sorry, OSPF enabled, and you cannot use ISIS to have an LSP that traverses routing domains. Routing domains. Okay, so let's see if that passive mode is enabled anywhere, because that looks interesting. And the reason I want to do that, aha! So yep, it very much is. So I just wanted to do that quick to make sure that these are going to align. Inter-AS traffic engineering requirements. The proper establishment and functioning of inter-AS traffic engineered LSPs depend on the following network requirements, all of which must be met. All ASs are under control of a single service provider. OSPF is used as the protocol within each AS, and eBGP is used as the routing protocol between the ASs. ASBR information is available inside each AS. eBGP routing information is distributed by OSPF, and an iBGP full mesh is in place within each AS. Transit LSPs are not configured on the inter-AS links, but are configured on the entry and exit point ASBRs on each AS. The eBGP link between ASBRs in different ASs is a direct link and must be configured as a passive traffic engineering link under OSPF. The remote link address itself, not the loopback or any other link addresses, is used as the remote node identifier for this passive link. For more information about OSPF passive traffic engineering mode configuration, see configuring OSPF traffic engineering mode. In addition, the address used for the remote node of the OSPF passive traffic engineering link must be the same as the address used for the eBGP link. For more information, see that. So inter-AS traffic engineering limitations. Only LSP hierarchical or nested signaling is supported for inter-AS traffic engineered LSPs. Only point-to-point LSPs are supported. There is no need for point-to-multipoint support. In addition, the following limitations apply. Any one of these conditions is sufficient to render inter-AS traffic engineered LSPs impossible, even if the above requirements are met. The use of multi-hop BGP is not supported. The use of policers or topologies that prevent BGP routes from being known inside the AS is not supported. Multiple ASBRs on a LAN between eBGP peers are not supported. Only one ASBR on a LAN between eBGP peers is supported. Others ASBRs can exist on the LAN but cannot be advertised. Route reflectors or policies that hide ASBR information or prevent ASBR information from being distributed inside the AS are not supported. Bidirectional LSPs are not supported. LSPs are unidirectional from the traffic engineering perspective. Topologies with both inter-AS and intra-AS paths to the same destination are not supported. In addition, several features that are routine with all LSPs are not supported with inter-AS traffic engineering. Admin group link colors are not supported. Secondary standby is not supported. Reoptimization is not supported. Crank back on transit routers is not supported. Diverse path calculation is not supported. Graceful restart is not supported. These lists of limitations or unsupported features with inter-AS traffic engineered LSPs are not exhaustive. Configuring OSPF passive TE mode. Ordinarily, interior protocols such as OSPF are not run on links between ASs. However, for inter-AS traffic engineering to function properly, Information about the inter-AS link, in particular the address on the remote interface, must be made available inside the AS. This information is not normally included in either eBGP reachability messages or in OSPF routing advertisements. To flood this link address information within the AS and make it available for traffic engineering calculations, you must configure OSPF traffic passive mode for traffic engineering on each inter-AS link. You must also supply the remote address for OSPF to distribute and include the traffic engineering database. To configure OSPF passive mode for the traffic engineering on an inter-AS interface, include the passive statement for the link. OSPF must be properly configured on the router. The following example configures the inter-AS link to distribute traffic information. Okay, so I really understand things now. I've really got a better sense of what's going on. So what's going on is just as we attempted to share more routes, and you can see we're advertising routes to the other side, and as such the other side is learning these routes. We also have to do that for this traffic engineering database here. It has to be shared to this side. This side needs to know the same traffic engineering database information as this side does. And I don't think there's a way to share that if you're using different protocols, because ISIS, I'm not sure if it can take traffic engineering database information from OSPF. So I think they have to both be the same, either OSPF or ISIS. I wish I had time to dive into it more, but I think I've only got like 4 minutes, if that. Even that's kind of a stretch. So let's, oh God. I don't want to give it up because I finally know where the goalposts are. I mean, I've got to share the TED information, and I know what link I got to share it on. I got to share it on GE2 or GI2. Yeah, GE002. Yeah, so I've got to send the traffic engineering database across so that ISIS can eat it. So I do edit protocols MPLS, edit interface 002, and then set but it's not going to be under here. It's going to be under, so edit protocols OSPF, edit traffic engineering. Shoot, I mean it says how it's done here. It's going to be yeah, so it's going to be under the interface. So we're going to do so it's going to be under so if I go up and I go edit area 0000, I do edit interface 2 that's 0. Now I can do set passive traffic engineering remote node ID and then 10.0.5.2. Okay, so now I'm sharing my traffic engineering database. If I sniff this link, we're gonna see it sent out, but I don't think this side will be able to use it since it's running ISIS. But I think if we had OSPF set up on that side, we get the LSP to come up. I'd love to check that and verify that, but unfortunately, I'm just plain old out of time. So I wish I could see the traffic engineering database being sent as well, or at least some OSPF data Let's see if we can figure out the equivalent command for ISIS. So we're going to do edit protocols ISIS, and we're going to do edit int GE0002 .0. We're going to do set. Now this is going to be traffic engineering. So before for OSPF it was traffic engineering remote node IP. Maybe there's something like remote node IP. Nope. Maybe there's something like traffic engineering. Nope. So like database, something like that. Anything like that. Link state database, link degradation threshold, link protection, LSP interval. Nope. So I don't see anything. I don't see anything like that to share the link state database, unfortunately. So I'm gonna throw in the towel. I'm gonna take an L, and thanks for watching. I'm gonna mark this as done, and I will see you in the next video. We're going to be going over IBGP, IGP, BGP, whatever that means. So stay tuned. Thanks for watching.